do with applications in Linux. Multi-channel recording is basically the mainstay of music production, and I really don't think I can produce any amount of useful demonstration of the multi-track recording software on 800 by 600. I do have, you know what? Let's see what happens. So, Ardour is a application that's been developed for professional audio work in Linux. It's been around for quite a while. It's quite stable. It is basically it allows any number of channels to be recorded. It allows that audio to be routed in any arbitrary way. So when I recorded this audio here, let's see what it looks like on that screen. It might not be useful. Okay. Yeah. And this sounds like an AD interface. Okay. What I have here is a recording from 16 different audio sources located all over the stage of the Humanities Theater at Carnegie Hall during a production called FAS. It is a amateur theater company that puts on a ridiculous musical theater comedy that we write and produce every year. This year I was a pirate dressed up as a parrot, singing Taylor Swift lyrics. It was actually kind of ridiculous. But what I did during the production is I had a microphone on the right side of the stage, a microphone on the left side of the stage, a microphone on what's called the slot, which is the side of the stage in front of the speaker grate, and then one on the left. Here's different scenes take place out there. Then I have a feed from the piano, the guitar, the bass player, the drum. I have a mix of all of the brass instruments of the band. I have the alto saxes and the clarinets, and I have 5 microphone inputs from each of the solo singer microphones that were used during the show, and I have a feed from the computer that was playing the special effects, all recorded on separate tracks.
Is this going into a computer or going into software?
This was actually both. I had access to, the guitarist in the band had a number of these Roland digital mixers. It's a rack mount unit with a digital panel that allows you to do all of the functions that this device here does of controlling audio levels. It also has a USB port on it, and when you plug a computer into it, what you get is 16 channels of digital audio from each one of those channels, plus 2 more channels which are the stereo mix of whatever that board happens to be currently outputting, available as recordable devices in the computer. I was so happy when he said I could use it. I ran a USB cable from my laptop down to the pit to test it. I plugged it in, I brought up the software, and it all just worked. It was so awesome. There was no configuration, no drivers, no nothing. I plugged it in, and it started working. This is the other window, which provides the mixer, which does look is intended to provide the same functions that this device here does. Each one of those channels has a volume control, pan control, the ability to enable whether or not I'm recording on it. None of those should be active right now because that would be messy. Just in case I want to turn those off. What these functions allow you to do is play an instrument and record it, and then play back that instrument while you record another instrument. One simple way for a band to do a recording is to just have them all play their instruments, one on each track, and basically do a rough take so that each musician has their bandmates to play with. And then you can sit down with the guitarist and you can play him all of the rest of the band except the guitar and have him play and record a new copy of his guitar track into the software. You can also, in traditional studio equipment, you have what are called inserts, where you have a device like a compressor. A compressor, quickly what it does is it takes an audio and it amplifies it. But if the level of that amplified audio goes beyond a certain point, then it automatically turns it down. So you're compressing the dynamic range is how they get the name. So what it means is the quieter parts are louder and the louder parts don't get as loud. It's very handy in vocal performances because most non-trained singers can't keep a consistent level of power in their voice. Certain instruments are very difficult to play at the same volume all of the time. Bass players. So these controls here allow playback. So what I'm going to do is I'm going to find a part of the show that has the band playing, which is going to be very difficult because I can only see half of the face. But just the guitar. Just the bass player. So what I can do in this interface I can turn on the bass, I can turn down the bass. I can set the level of the drum. It is the basic. About to get to my part of the song that's really silly. So it allows any number of channels of audio to be recorded and played back, routed through additional devices, and edited. You can cut, paste bits. You can record multiple takes of the same part, and you can decide which parts of which one. You can actually take each individual attempt at playing it and cut and paste which parts of it actually work. So if you screw up the first half of the song the first time, and the second half of the second, you can edit the different takes. You can apply filters, effects processors, compressors, and produce a final mix. It's basically what every musician in a studio does. And all of that software is available. Unfortunately, I could do an entire presentation on this. It would also help if I was actually a musician, because being able to play something is kind of helpful. But because I can't actually demonstrate this software in any practical manner, I'm just going to move on. Okay. So, cool stuff. One side decides to die.
Is it don't we?
What was that? Oh, that's what I was aiming for. Okay, so, step 2. Okay, this is going to be a little weird because there's a bit of a delay here, but, the YouTube series Auto-Tune News. What they do is they take footage of politicians and famous people from the news, and they put to music. So there's not quite the audio quality I was hoping for, but you've all probably heard of Auto-Tune. Auto-Tune, in its basic form, allows a person's musical performance to be adjusted. If they don't sing exactly on pitch, it can be, and what that software was doing is it was attempting to figure out what note I was singing, and then was adjusting it on the fly to be more accurate to the pitch of the note that it thought I was singing. So you see as I talk, if I'm just gonna sing a note, you can see on the interface that it's actually deciding what note that I'm actually singing. What T-Pain's entire music career is based on, and in addition to Auto-Tune the News, is the ability to, instead of having it just adjust it to the closest pitch that I'm singing, to actually tell it to adapt the sound to a pitch. So as I'm talking, I can make my voice sound almost musical. I can bring it low, and I can bring it high, and I can change the tone of my voice, and I can play something I can actually play. My voice as an instrument. So it is definitely a fun one if you can. The one thing about Auto-Tune is that the more that it has to adjust the pitch from what you're actually singing, the more artificial it sounds. The first song that made it famous, of course, was Believe by Cher. It's her singing, do you believe? And as soon as she sings Believe, you take this pitch bender and you go, wah, and it adjusts the audio to the pitch of her voice to match that. It was a novelty effect that became huge, and it's used all over music these days. There's a couple of rappers, T-Pain being the most famous one, where his vocal performance is basically a rap, but they've actually introduced that melody using Auto-Tune. And he actually had the audacity to think that the company that designed Auto-Tune was marketing it owed him money for making it famous. It was hilarious. So that's one of the tools that's actually included with the Ubuntu Studio distro. I guess I should mention Ubuntu Studio. It's one of the flavors of Ubuntu. Let's start pronouncing it correctly now. That has a whole bunch of software that's intended for content creators. It's got an entire suite of music production software. It's got all of the graphics tools from GIMP on through 3D rendering software like Blender, all pre-configured. It's got video editing suites built into it. And it also comes pre-configured with a of the configuration of the kernel that basically what they define it as is the maximum amount of time it can take to process an interrupt. So if the sound card signals the processor that it needs attention, it has to respond within a certain amount of time. It's important for a lot of industrial applications as well. There has been versions of Unix that have been built from the ground up to be real-time operating systems almost forever. But it was not something that was considered that important because there is an overhead involved in that. So the overall user experience can suffer a little bit for something that's really not of that much importance to the average user. But what I'm running right now is another sound server. This one's called Jag Audio Connection Kit, or Jag. It's one of those recursive acronyms. It's currently running. This here you can barely see 17/30. What that is it's the number of times since I started this, just as the break started, where the computer has been too busy to process it around. If I was doing professional work, I would have to change the settings or use a much more powerful computer because this thing's a bit of an antique now, so that what I'm doing is not overloading the real-time kernel such that it can't keep up. And what this does is basically the same thing that the other sound servers do. It provides an interface between the hardware and the applications. The difference with this one, though, is it actually has the ability to treat this interface to the screen. All of the applications that I'm currently running can basically be connected together like they were actual physical devices connected with wires. So I have in the system here, well, ignore the pulse audio jack sync and jack source because I'm not using them, because I shouldn't be using them. And they are no way, don't worry about it. But the basic inputs are in the system category. This computer has an audio jack which provides 2 channels of input. It's generally left and right, but that designation is not necessarily relevant. I can have 2 microphones attached, one on each channel, and record them separately in separate channels. So I can use that hardware software and record 2 microphones just with this laptop with a standard audio interface. It's a bit noisy, I have done it, and there's a background noise which is noticeable. It's a little bit better if I run off the battery and actually unplug it from the main power when I'm doing it, but I generally try not to do professional work with the internal audio. On the writable client side, you have playback 1 and playback 2, which is the left and right channel of the output. So if I were to take this and connect it to this, what I would have is the microphone input being played at the speaker. Not that useful. What I do have, though, is I have the input connected to the auto input package, to its input. So anything that came through the microphone is going to be input of that software, just like it was a microphone attached via wire to the auto-tune unit. And that device generates a stream on the output, which has been set to playback. It takes a single input as mono and outputs a single output, so I just told it to go to both left and right simultaneously. So that's basically Jack in a nutshell. It also provides the same functionality for MIDI, because most audio interfaces these days don't have MIDI built into them. I did actually purchase this device here, which is an M Audio 1-in, 1-out MIDI interface. It was like 40 or 50 bucks. It has the standard MIDI jack, which is a 5-pin DIN connector on each end. Most equipment that you buy nowadays bypasses the need for that type of thing. If you buy a modern M Audio or a licensed keyboard, it will have a USB jack. When you attach the USB jack, it will become a MIDI device that happens to already have a keyboard attached to it. The DJ controller has a MIDI device that already has a quote-unquote keyboard attached to it that provides the button functionality to the DJ software. And actually you can see that here, that's the Studio 4A. I don't currently have any applications running that would actually make use of that. So it's not connected to anything. But I've connected the MIDI interface, which is connected to the keyboard. So the keyboard connects to the MIDI interface, which connects directly to the Hextra application, which is running here. I did demonstrate this last time, so I won't go into it too much, but this is basically a hardware implementation of the Yamaha DX7 keyboard, which pretty much every musician in the 80s owned. It's accurate down to the point where it came out before the MIDI standard was finalized, and so was only ever compatible with MIDI channel 1. The MIDI standard can have 16 simultaneous channels, so one's cable can address 16 different instruments. either in a single device or in multiple devices, but this keyboard predates that, so it only ever worked on channel 1. So it's basically just a series of instruments which were apparently the standard ones that came with the instrument when you bought it. There's also a, I don't actually know how to do it. Oh, it actually go. These are basically all of the controls that the keyboard, it's the actual physical Yamaha DX7 had. And it worked out to like a table of about 128 different values that you could set. So if a musician found an instrument that they liked by playing around with the knobs, they could store it on a floppy disk and then recall it at any time. This software actually will read the contents of those floppy disks and configure itself to be exactly the same as those patches from the original Yamaha DX7. But another thing they found they could do is they could just take those 128 settings and write them in a table and publish them in a magazine. So there's a few musician publications where they would have instruments that they would share just by listing all of the settings, and you would go in and manually set your DX7 with all of these settings. And then you'd be able to play the same instrument that these other musicians are playing. So it was a way of sharing it. So it is actually simulating the actual Yamaha DX7 at a hardware level. So this is its basic piano sound. And that's a standard electric piano sound. It sounds kind of sucky. The other ones. Its attempt at a guitar sound. Some less intended to be naturally sounding instruments. One thing that I did mention, I found this and I couldn't figure out what it was initially, because I knew I'd heard it before. That is the instrument that is used to play the opening sound effect of the Final Countdown by Europe, because they were musicians in the 80s, they had a Yamaha DX7. So these are just the ones that attempt at drum synthesis. Another thing that I demonstrated last time, I'll do quickly, hopefully it works. I'm not going to figure it out. But what this is, it is a pipe organ simulator. So, let's see. Where should this work? So I'm connecting these just like connecting them with wires. Here we go. So what this represents is all of the physical pipes that would be in a church organ. of pretty much any size. I'm assuming that most of them don't have this many options. But the pipe organ would have little knobs that you would pull in and out, which would enable the pipes to resonate. And what you would have before something like this is the option of a simulated organ sound, which would have sounded something like... Obviously, there'd be some that would sound a little bit better, but that's not quite what you're expecting to hear in terms of a full organ at a ball game or at a church. But by actually mathematically simulating the actual pipes in the organ, you can get change the tone by adding more pipes. I'm just randomly doing this, so I'm not sure what the actual sounds of doing it. Play some minor chords here. If I can remember how to do that. So it's by actually using some science, you can actually simulate sound at a much more realistic level. I told this story last time, I'll do it quickly. Back when I used to go to church, the church in my hometown had a pipe organ. And it still worked, but they were worried about not being able to afford the maintenance, so they were thinking about selling it. But they didn't want to because any option that they would have to replace it would have sounded awful. By comparison, they did have a beautiful sounding organ, which was basically the entire corner of the church was this cabinet that held all the pipes. I've never had them back there anymore. Like, I have no idea what they're doing these days. But an option like this might have worked out for them. So moving on from that. There's something here I was introduced to. The concept of this. Not being able to actually play as a musician limits my ability to demonstrate this, but what it is, it's a loop recorder. It starts by recording something, and then it plays that back, and it records the next thing that it hears, and it plays and on a loop, so it's continuously playing the first thing it recorded, and as it goes, you can add on more sounds. So you would play one part of a song, like the bass line, and then you would hit stop, and that's the loop. And then you repeat that bass line, and on top of that, you play another part of the song, like the melody. And you can layer on and layer on and layer on different voices in the song, and then stop that, and it would just continue playing it. So I've seen some demonstrations by talented musicians where a single violinist with an electric violin and a number of effects pedals, the same kind of effects pedals that you would use with an electric guitar, was able to, in about 7 or 8 layers, put together a performance of U2's With or Without You. It sounded absolutely amazing, with a single instrument recorded on the fly, one loop at a time. But there is one thing that I thought about when I was testing this. I tested it with a very simple sound, and I realized that it would be one demonstration of how it works. It would work out fairly well. We'll just take a moment for me to set it up there. Like that. And capture to
surprising they don't have the ability to save settings.
They do, I just haven't bothered with it. There is, I'll bring it up in a second. I show you how on the fly this presentation is. But that patch right here is where you would define connections that would be reinitialized whenever the requisite combination of apps pop back up. So once you've launched your drum machine, it will make the same connections that it had last time. And there's another app which does this in a much more complicated way, but it's unfortunately very unstable. It does the same thing in a very visual way. It's trying to auto-arrange the things, and it's too complicated. It can't. And it will eventually crash. So I don't use it very often. It won't stop the server when it crashes. It'll just be annoying. So what I should have here. So you can see the level of the input there. So what I'm going to do is so that's unfortunately I did not get a good capture, but that's not that important. Because that's what it's doing, it's playing what I recorded over and over again. But then if I click on overdub, what it will do is it will continue to add more recording of that length. I could build up an entire audience cheering for me with one set of headphones. That is a very simple demo of how it actually functions. And how do I stop this? I don't know how to stop it. So we'll just start. There's musicians can use this with much more pizzazz than I can, and it's usually implemented in a set of foot pedals, so they can stomp on the pedal as they're playing their instrument, and then on beat stomp on the pedal to end the loop and start it over. So if they start 2, 3, 4, 5, 6, 7, 8, stop, and it will immediately start over from the beginning. And you will have a continuous time of music that they can then lay more tracks on. And I've seen musicians do it live because if you sequentially lay on the tracks and you can build a song from scratch in as long as it takes to play the song 16 times. It's really quite impressive. So what time are we at now? We're pretty much at 9 o'clock. Does anybody have anything else that they wanted to do with audio? There's something that I should mention this. What I wanted to do was actually demonstrate a live, basically do my presentation in the form of a live radio station where I'm using a player engine. I can show you the interface here. Unfortunately, that would have required me doing the presentation from a different computer, and that one isn't working right now. But what's the rules for maximizing this? The entire window have to be on before it will allow me to do it? No, I think I might just have the smallest level. So,
If you double click the
so what this basically is it would be the controls that a DJ would need in front of them to run a radio station on the fly. At the bottom, it does have some interfaces to VoIP systems so they can take calls. They can enable their microphone or an auxiliary microphone if they're doing an interview with the live guest. They can queue up music. I don't have the computer, I don't have time to do it, but they can sequence tracks while they're playing. In this interface here, they can have like station promos that while they're talking, they can just hit this button and it'll do the station promo and have their advertisements lined up so that when it's time to play an advertisement, more after this, hit the button and the advertisement plays. And it's a very simple system for basically live streaming the podcast. Is the easiest way to look at it. It can then be captured or sent out live via an internet streaming system. There are more elaborate ones as well. There's a network of religious radio stations didn't want to pay $1 million per station for their 850 stations in the U.S. to have a professional radio station play engine. So they just paid someone like $1 million to write one for them, and that was called Rivendell, and it actually was created with open source software. So it is available under the GPL license. Far more complicated. It actually has engines for DJs to go in and pre-program music for the future. So they can say, I'm going to play these songs, and I'm going to record the DJ voice that goes in between these two songs. So next up, and they can record all that information, sequence the songs, and then store it on the playout engine, and it will just automatically be fed out to the transmitter. It's a very elaborate piece of software. It doesn't have that much public interest, so it was never really polished and it was very nice, and I was never actually able to get it going. It was also designed specifically to work with the sound cards that are required for direct interfacing to large-scale transmitters, which is less useful, but it does support Jag for other options as well. What I wanted to do was talk about different pieces of software by creating advertisements and play them during my presentation. This is Audacity. A lot of people are familiar with. If you want to do basic audio editing, this is probably your best bet. It's harder, as I demonstrated before, but on a smaller scale. You can import different tracks of audio. You can use the microphone to record something. So you can bring in your background track, and then you can record via the microphone your voiceover, and you can see the waveform. And at any point where the vocal waveform is there, you can modify the gain envelope of the audio track so that it's quieter when you're talking, and then gets loud again. So you can do simple editing like that. You can cut audio into pieces, so you can pull out certain bits of a longer interview. We have had a presentation on the software in the past, and it's a very useful tool. It's cross-platform, it's available pretty much across the board. Everybody's using it these days. There is software that does musical score notations. And most of these are not designed for something to edit the musical notation. To being able to modify notes. And it actually, all of these annotations, there are conventions on how to do it where, to be as clear as possible for people who read music, and it will follow those automatically, it will make the adjustments on the fly. There's a couple packages like this. There's another one called Tux Guitar, which does the same for guitar tabs. Guitar musicians have a series of lines where it indicates on each line what fret on the fretboard you're supposed to be holding when you play that string. So if one of the lines has a 5 on it, you hold that string on fret 5 and play it. And it will allow you to create those diagrams, and it will also, because that references an actual note, it will put that on the musical staff and show them side by side. Good tools for guitar players, musicians. You can see it obviously handles fairly elaborate stuff here. So people who compose music. And the other thing is you can write something on here and then output a MIDI file, which will have multiple staffs for multiple instruments, which can then be attached to different sequencers to render that song with electronic instruments. So that does bring us to 9 o'clock, and it's a reasonable place to stop. I've got through pretty much everything I wanted to tonight, which is good. Most of it was stuff I wanted to cover last time and didn't get to. Those were technical problems, and I didn't get to show DJ, but it's not that Linux specific, and I definitely can't fit that in 800 by 600. But it's a software interface that simulates multiple CD players. You can it shows the waveforms as they're playing. These controllers here, when you touch them, it's the equivalent of putting your hand on a record. It stops the playback, and you can wind the record back, and you can scratch it. When you let go, it detects the lack of contact with the disc, and as soon as you let go of the record, then resumes. It is compatible with what's called timecode records, which is an actual record playing on an actual record player, but instead of having music, it has a signal on it that the computer listens to. They can tell it exactly what's happening with the song, where it is in the song. It knows it's a minute and a half in, and it knows that you're winding it backwards, so it's playing the song on the computer from a minute and a half point backwards. And it allows DJs to use a computer with actual records, which most of them that's what they learn what they want to do. It allows them the most dynamics of their performance. Anybody who's an actual DJ probably uses it because they wouldn't get much respect otherwise. I don't. I'm not one of those DJs. I'm the type of DJ that actually just plays the music the crowd wants to hear, which is not the same as most DJs apparently. But yeah, so that's as much as I can do here tonight. Thank you very much.